Alright guys, this video is on ANCOVA, and it's, as you can tell from the name of the technique, it's probably very closely related to ANOVA that we've looked at recently, and again so far we looked at ANOVA and two-way ANOVA. So I wanted to move into ANCOVA because it's a design that's used quite often in education research. And we'll look into this and see what's going on. First thing I want you to know that there's only going to be 2 videos up this week, and there's not going to be an additional assignment. So you, I think, on Wednesday have got your write-up for your two-way ANOVA that's due. So that'll be the only thing that you'll submit this week. And the assignment on ANCOVA will be another kind of group exercise this Friday on our on-campus session. So that's what's going to happen. So yeah, probably compared to most weeks, it's a little easier week. So enjoy. Okay. All right, gang. ANCOVA again. ANOVA is analysis of variance, and ANCOVA is analysis of covariance. In this case, the Kentucky accent is too bad. I'll always write this out. So analysis of covariance. The concept of analysis of covariance brings in a new term, or a relatively new term, I would think. And it brings in what we call the covariate. Now let me get my coffee straight here before I get going too crazy, okay? We've got to get our priorities here, and right now my priority is coffee. Okay, gang, let's just stop back a little bit and from covariate. Let's think about what covariance is. Now, if we look at the covariance from X and Y, the covariance formula well, let's just say degrees of freedom. I'm not really sure what that would be. Looks awfully close, very similar to the variance formula. And if you recall, the variance is just the sum of the deviation squared over its degrees of freedom. So a good way of thinking of the covariance is the covariance is just a more general presentation of the variance. And it's fair to say that the variance is a subset of the covariance, because the variance is really just looking at, the covariance is kind of looking at the relationship between 2 variables, while the variance is just looking at really kind of how the variable varies within itself, if you will. Now, let's go back and think about something here, and let's say let's kind of examine what could happen when our x's and y's are different forms of variables. And let's say that we have a categorical and we could possibly have a quantitative y. Categorical and a quantitative x. Now, if we have a quantitative x and a quantitative y, I hope you know by now that we could examine the relationship between the two using regression. I hope you realize that if the x is, if your independent variable is categorical and your dependent variable is quantitative, then we would do an ANOVA. just for the heck of it, it doesn't really apply to this video, but what if we had y is categorical and x is categorical? Well, in that situation, we would probably look at the relationship by conducting a chi-square. But there's also ways that we could, if the categorical variable is in zeros and ones, then we could use a logistic regression. Speaking of, if the predictor is quantitative and the outcome is categorical, and again dichotomous, then we could use logistic regression. Now, if logistic regression can be expanded into ordinal regression and multinomial regression, but right now let's just keep it here. So where does ANCOVA fit into this design? Well, a good place to consider ANCOVA is it kind of fits right in here. We still have a quantitative y that we're wanting to explain, but we have a categorical dependent variable and a quantitative dependent variable that we want to control for. So in this situation, the quantitative variable is called a covariant. Now guys, covariates don't always have to be quantitative, although they usually are. But I think in most of the presentations that I'm going to do, in this class, we're going to look at a covariate being quantitative. So, guys, what do we need for an ANCOVA? Well, we need, first of all, our y to be quantitative. And we need our x's to have at least one categorical variable and at least one quantitative that we'll call our covariate. Now, you can generalize this more and more, but this is what I want to focus on for the nature of this class. Now, the next thing that we talk about, let's talk about something you're going to hear me talk about a lot, is just a general linear model. In a general linear model, at least for me, just says that our dependent variable can be expressed as the explained variation plus the unexplained variation. And guys, consistent in my class, I usually call this the error. The error variation is just the variation that we can't explain. Now, what we seek to do in ANCOVA is this. Let's say that we have, I don't know. Let's say that. Oh goodness. I'll tell you what. Let's say that we are. Let's do something fun here. Let's say that we're dealing with golf instruction, and we have a golfer that comes in, and we give them an initial skill set, and then when they complete our program, we give them a final skill set. And it may be interesting enough to come in here and look at the relationship between x and y. And we would, I don't know, maybe hope, maybe not, who knows, hope that we have some relationship that maybe looks like this. Now, let's say we brought in a couple of treatments. Then let's just call these treatments A and B. So A is, we have one golf instructor that thinks that they can improve the skill score from the initial to the final. by using their particular type of golf instruction, and maybe golf instructor B thinks that his or her is better. So we'd like to compare these. So guys, notice that our y variable is quantitative. Now I don't know. Let's just say that this golf instruction skill set is somewhere from, the scores range from 0 to 10. Okay. So for example, we have one person that comes in and they have an initial skill set of 2, and they end up leaving, and they've improved their skill set from 2 to 4. We have someone else who's a really good golfer who comes in at a 9, and they leave at a 9. So in that situation, you would say that the treatment wasn't effective. It didn't hurt the golfer, but it didn't improve. Now imagine us having kind of 2 sets of lines here, and just for this, without loss of generality, let's just say that this is treatment A and treatment B. So ultimately, what we want to look at is we want to look at the slopes of the regression lines, and we tap into this using a system called ANCOVA to conduct our overall model. So we're going to see this, in pretty cool setting, I think. So the first thing, again, I'm just trying to get through, kind of talk it through. Let's talk about ANCOVA, talk about covariates, and look at the motivation for what we'll do actually in the next video. So first of all, again, ANCOVA is just what we call a general linear model, and it's just an extension of ANOVA, which I assume by now we know pretty well. Now, an example we may want to look at, let's say that we have a quantitative variable, which is our y, that is the AP final score on the statistics test. And we would like to see categorical variable x is private, public, or charter school. Now, guys, with a quantitative y, I'll tell you what, guys, hold on. I've got somebody's outside. Something's going on. Let me check it out. All right, sorry about that. My daughters are leaving for church camp today, and so the church bus. Actually, they're going with my neighbors, who are the deans of the church camp, and the bus, whatever is over there. So, wondering what's going on here. Okay, guys, where are we? We're going to look at the difference of AP final test scores for statistics across private, public, and charter schools. Well, I would hope that you know by now that this is a classic ANOVA, right? We're going to compare group means for public, private, and charter schools. And our alternative, I'm not going to write it out, but we've seen this ad nauseum. at least one pair of means is statistically significant. Now, someone could make the argument that private schools, for example, have smarter kids. I don't know if I really buy into that. I don't know that I don't buy into it. I guess it depends on the public school and depends on the private school. There's no question about it that a lot of very bright kids go to private school, but there's no question about it. I've seen a lot of very bright kids go to public school, and honestly, I got to tell you, I don't know much about charter schools, so I've never, really seen the motivation to send kids to private school. I guess unless unless the public schools in the area aren't very good, or obviously maybe some religious motivation. But then again, who knows? Maybe one day my kids will be going to private school. I have no idea. But anyway, if we wanted to look at this, we would run an ANOVA. And again, someone may say that, for example, that maybe kids that go to private schools, day in, day out on average, are just better at math. Well, if you would want to do that, if you would want to address that, you would come in with a covariate. And what I would want to do here in terms of a covariate is I would think of some observed measure, so we're not manipulating it, that we'd like to control for. So some observed measurement we would like to control for. Really, you're not really controlling for it, you're just kind of adjusting for it, but controlling for is just terminology that's going to come up quite a bit. So what we would like to do, and I will tell you that the classic covariate is a pretest score. But so in this situation, we might want to come in with some sort of prior math score. Now, why would we want to do that? Well, let's go back to something cool. No, not Kentucky basketball, although it is really cool. Let's go back to something and let's talk about golf. So let's say that I come up with a 2-day training session. That I say will guarantee to improve your golf skills. So unfortunately, my first training session isn't very popular, and I only get 2 customers. To get an indication of the type of customers that I'm working with, I give them a pre-skills test. Okay, and let's say that the tests range from 0 to 10. 0 would be a very poor golfer, and let's say that 10 is just a scratch golfer. Okay, so I give my participants this, and let's say that golfer number 1 scores an 8, and golfer number 2 scores a 4. So after the 2-day training session, have them take the skills test again. So let's just call this a pre-test. And let's call this a post-test. Well, we give them the skill. Again, they go through the training sessions and so on and so forth, and they take the test again, and golfer number 1 gets a 9, and golfer number 2 gets an 8. Now, if we look at this in terms of isolation of other measurements, it would appear, if we just looked at this comparison right here, in isolation of this information right here, it would appear that my 2-day training program worked best for the first golfer because they ended up with the highest score. Now, it's not easy, it's no stretch of the imagination to bounce this off of private, public, and charter schools' average scores, right? Just because the average is bigger doesn't mean that the treatment was more effective. Well, not unless we get a baseline. And guess what we call this baseline in statistics? We call it a covariate. So looking at a baseline of where we started and where we ended, golfer number 1, improved his or her game by 1 skill unit, but golfer number 2 improved his or her by 4. If we don't come in and control for the baseline, then we don't have any way to really tap into the effectiveness of the treatment. Looking at the end means just gives us a comparison of the means, but again doesn't assess, or I should say control for or adjust for the baseline. So guys, this is something, again, I told you the other day, Math 6600 is all about trying to get you ready for educational research. And it would be no stretch of the imagination that we may implement some sort of teaching instruction, maybe compare with a control group. And if we want to truly tap into the effectiveness of the instruction technique, we need to control for the level of students that we started out with. Now, there are sometimes we don't have to do that, and we'll talk about that eventually too. Okay, so what's going on here? Sorry, gang, I need some coffee here. To me, it's reasonable to assume that within each type of school, charter, public, and private, there's going to be some variation in the entering student, or the students entering math level. Now, that should be very, very, very clear and not even arguable. If you don't control for this entering math level, then that just creates what is called unexplained variation. Well, in statistics, we like to minimize unexplained variation because unexplained variation will just confuse our model. And unexplained variation will cause the mean difference, the true mean difference, to get caught up in what we call noise. And noise is just, again, unexplained variation. So guys, to eliminate the noise and control for the unexplained variation, we would use maybe a pre-math test score as a covariate, something we could control for, and thus we could get a clearer picture of whether the differences in the average or the mean AP statistics scores is different due to the type of school, or simply because one school or the other just started out with better students. Now, I hope this is clear. This was kind of, for me, because I love statistics, it was kind of a life-changing thing, because I always wondered about, when running just simple models, what happens if there is this extra noise or unexplained variation due to just having better students? How do we take care of that? Well, this is the way we take care of it in this situation. Now, you can actually take care of covariates 2 different ways. So we can think of covariates in terms of the same as a continuous predictor variable. Now, guys, over here, this would be a regression model, and over here, this is an ANCOVA. Guys, both of these are just general linear models. This over here is going to contain an intercept. The ANCOVA doesn't contain, well, actually, some Sometimes it does, but the one we look at is not going to. The big difference, the biggest difference here, is in regression, we can actually come in and state a hypothesis for the continuous predictor variable. When we use it as a covariate, it's just something that we control for. So, and, you know, in the ANOVA or the ANCOVA, the model doesn't care that the covariate is something we don't have a hypothesis for. Mathematically, it's the same, but in the regression perspective, we actually set up a hypothesis that the slope is not equal to 0, and you know, carry out t-tests and p-values and things like that. That's not the issue over here. The issue over here is let's just adjust the variation and make it happen. So it's clear that some people who understand this often use the term covariate to mean any continuous predictor variable, whether it's a control variable or predictor in your model. I guess in the end, at the end of the day, it's easier to say covariate than continuous predictor variable. So maybe that's the reason people get that get it confused. I don't know. All right, where do we want to go from here? Now, if our end goal is, let me just show you how this could work. If our end goal is AP score, and we want to look at the variation across X equal type of school, and we also come in, we want to see that we need a covariate. And we want to, let's just call this X1, and then we want to covariate X2. First of all, we could have this in terms of either a quantitative or a categorical variable. Pen went crazy on me. Quantitative would be maybe an entering score. And a categorical could be something as simple as, did you take calculus? And I would think it'd be pretty clear that both of these would kind of give you an indication of entering math level, but I think it's pretty clear that the quantitative measurement would give us the best. Now, what we're going to ultimately get into and find out that a single question like this is not really a good indication of really of anything. Once we'll get into some factor analysis and stuff, but so guys, let's see, where do I want to go from here? All right, what really happens here? All right, if we go back to go back to ANCOVA. Now, okay, what? Because I got to admit, I am distracted by what's going on outside. I think they're getting ready to leave, so that's going to be a good thing. Hope you're not asleep yet. Okay. So what are the advantages of using ANCOVA? Well, first and foremost, it reduces the error variance. And obviously it gives you greater experimental control. In other words, it lets you tap into more of the effect of the treatment by using the ANCOVA model. Now, a good way of looking at this is in a simple ANOVA. We have the sum of squares for our total model that can be expressed as the sum of two components. The sum of squares for our model plus the sum of squares for the error. In other words, the explained variation and the unexplained variation. Now, bring in ANCOVA. And this is what happens. We have our sum of squares total, which is still the sum of squares for our model, plus the sum of squares for the error. But what this does, it will tap into the sum of squares for the error and explain more of that variation, and bring it into the sum of squares for the covariate plus the sum of squares that's still unexplained. Now, what will happen because of the obvious addition component here, it will reduce the sum of squares for the error because we can explain more of that sum of squares that's attributed to the covariate. Now, there are times this doesn't work, and let me explain what happens here. If you run a model and you have a sum of squares for the total plus the sum of squares for your error, and this all comes back to like the sum of squares for the covariate. In other words, this sum of squares for the factor didn't remain stable. It was affected by the sum of squares for the covariate. Then you've got a situation where the ANCOVA design is not appropriate. And you never know when that happens. Well, actually, you do know what happens because you check for it. But you don't you don't know when it's going to happen. And again, I told you all the first day of class, I can't take you through all the possibilities. But what we can do is just get an indication, or get experience with each of these techniques, and then when we encounter things like that, we just have to deal with it. So that's something I want you to put on your radar, something like that. Okay. Now,